In this video, we're going to try to find the limit of this sequence defined by a to the power 2n minus 1 over a to the power 2n plus 1. So a is in R. The limit will depend on the values of a. Okay? Note that this a 2n plus 1 is never 0. Okay? The key idea that we're going to use here is, since we see that we have some a to the power n, that means we're going to be dealing with what a similar or a looking like a geometric series or sequence. Exactly, a sequence. So the key is that we know that if we are given a some number q to the power n, and we are trying to find the limit of q, we will have to deal with many cases. Okay, so this limit will be infinite if q is bigger than 1. Okay, if q is 1, it will be 1. Okay, it will be 0 if q is between minus 1 and 1. And it will be doesn't exist if q is in this interval, minus infinity minus 1, or I can say just q is less than minus 1. To see this one here, to see why I'm saying this, try to use your calculator and use minus 2 to the power n, or just minus 3 to the power n, and see the behavior of this one here. Okay, and you see that it's gonna be jumping. It doesn't have what we call a uniform behavior. That means it's following a certain path uniformly. Okay, it's gonna jump up and down depending on the values of n and the parity of n. Okay, that's what we mean doesn't exist, and it doesn't exist really because you don't know. Sometimes it's up, sometimes it's down. It doesn't exist. Okay, so so now we're gonna use this this idea here. Okay, so our aim is to find the limit of this this sequence. Okay, so we notice that we can let a equals 1, and therefore we get 0 over 1. Okay, therefore this is 0. We can let a bigger than 1. We can let a be between minus 1 and 1, and we can let a less than minus 1. Okay, and we're gonna use this fact here, or we're just gonna remember them. Okay, and by the way, try to know this one and know its proof and remember it by heart. You will see it when you deal with geometric sequences or series. Okay, this is good to know. Okay, so now we see that we have if a is 1, we have a to the power 2n minus 1 over a to the power n plus 1 is just 0. Therefore, the limit of un is 0. Okay? If a is bigger than 1, so we can factor out by a to the power 2n, and we're going to have 1 minus 1 over a to the power 2n over a to the power 2n, 1 plus 1 over a to the power 2n. Okay, so here I can cancel by this one, and I'm left with 1 minus 1 over a to the power 2n over 1 plus 1 over a to the power 2n. So since a is bigger than 1, 1 over a is less than 1, and I'm in here. So therefore this limit here is 0. Therefore the limit of un, in this case, it's the limit here, it's 1. So that means a is bigger than 1. If a is less than minus 1, this one will be positive because it has these 2n to make it positive. And I will stay in, and the same thing for here, sorry. And the same thing for this one. Therefore, the limit is going to be 1 as well. Okay? Okay, if a is minus 1, this one will be positive, and it will be bigger than 1 because and I mean this case, therefore the limit is 1. If a is between -1 and 1, okay, this limit here, so a to the power 2n minus 1 over a to the power n plus 1, 2n plus 1, this one here will be 0, this one will be 0, therefore I have the limit is -1. Okay, so how many limits do I have now? So now I see that the limit of un is 1 if a is bigger than 1. It's 1 if a is -1. It's -1 if a is in -1, 1. Okay, what happens when a is 1? When a is 1, I get 0. So it's 0, 1a equals 1. So I have 3 limits depending on where the value of a is located. So this means the value of this sequence depends on the value of a. And these are my limits. And I get them based on here and on some rewriting of the sequence. Okay, the key idea is this one here. Okay, so and noticing that we can rewrite this sequence here. Okay, and I think that's it for now. If you see any mistakes or any errors, or we make a lot of them, please let us know or comment. Okay, please like, subscribe, and share. Thank you very much, and I hope you enjoy this sequence. Thank you very much.